Hello and welcome to this tutorial on writing ionic formulae. There are three objectives. The first is to identify the valencies for the ions. These are the charges that they are given, that they have. The second is to adopt the crossover, also known as the crisscross method, to find the formula. And the third is to know what the ratios mean and to understand what the formula is telling us. An ionic formula, it includes a cation and an anion. Cations are positively charged ions and anions are negatively charged ions. Ionic compounds are formed when we have an ion that is willing to accept electrons and an ion that is willing to donate electrons, and together they form an ionic compound. When we write the formula and name them, we start off with the metal, such as the example given, sodium chloride. We start off with the metal, which is sodium, and the one leading is the non-metal. Much like potassium bromide, we have the metal, potassium, non-metal bromide, and iron phosphide, and so on. Now, when we name them, the non-metal suffix becomes "ide." So rather than saying chlorine, it becomes chloride, bromine is bromide, and phosphorus is phosphide. It is something that comes with practice. Okay, let's begin. Writing ionic formulae for silver sulfide. The first thing you need to tell me is what is in it. Well, we see that it has silver and we see that it has sulfur in it. So begin with writing the symbol, which is Ag for silver and S for sulfur. Now you have to write the valencies for each. These are the charges given, and they have these charges because of their position on the periodic table. Silver has a +1 charge, which means silver wants to donate 1 electron. Sulfur has a 2 negative charge, which means he is willing to accept 2 electrons. Now, if we adopt the crisscross method of these charges, you are only looking at the numbers. You do not look at the positive or negative. So I will do the crisscross method and I will use blue. So this 1 comes all the way at the bottom as a subscript for sulfur. This 2 comes all the way at the bottom as a subscript for silver. So the final, the formula is Ag 2 S1, and you always leave out the 1 as it is redundant. So the actual formula is Ag 2 S, and that's it. So what this is saying, that for every sulfur we need 2 silver, and that is then the formula. Ag2S is the formula for silver sulfide. Let's move on to the next. Magnesium oxide. Again, identify the elements that are in magnesium oxide. Well, we have magnesium and we have oxygen. Now you need to do the valencies for them. So what are their charges? Magnesium has a 2+ charge. That means magnesium has 2 electrons in his valency and he's willing to donate those electrons. Much like with oxygen, he has 6 valency electrons, which means he wants to gain 2 more. Now, if we adopt the crossover method, we are just grabbing the numbers, not the negative or the positive, and we bring the 2 all the way as a subscript beside the oxygen. Much like this 2, we bring them all the way as a subscript beside the magnesium. So your formula, which is not finished yet, is Mg2O2. This is saying that for every 2 magnesiums we need 2 oxygens. At this stage, we have a 1-to-1 ratio, and it can also be written as MgO. You crisscross the valencies, which we have already done, and because it is a 1-to-1 ratio, you need to simplify it, and the answer is not Mg2O2, the answer is MgO. Alright, now when we are looking at polyatomic ions, these are compounds, compound ions, where they still have a charge, an overall net charge, whether it be positive or negative. The brackets, they have multiple atoms in them. That's what polyatomic means. Poly means many. So these are a few examples of polyatomic ions that we can combine them with, which looks like we can combine them with cations to form ionic compounds. Alright, so aluminium sulfate. We know that aluminium sulfate has aluminium in it and it has sulfate in it. Now you have written the valencies, which is aluminium has a 3+ charge and sulfate, everything in the bracket has a 2- charge. Now if you were to do the crisscross method, we just grab the number at the top and we cross them over and bring them all the way at the bottom subscript. So if we bring the 3 all the way to at the end of the bracket, and this number 2 can go all the way around where the aluminium is, the subscript there. So the answer is Al2 brackets for the sulfate, SO4. Now that polyatomic ion acts as one ion, so everything in the bracket then is times by 3, which we got from the aluminium crossover. This means that for every 2 aluminium ions, we need 3 lots of sulfates. Now, what if you were to do the crossover method or the crisscross method with something like copper and sulfate? Now, copper has a 2+ charge and sulfate has a 2- charge. If you do the crossover method, you would get something that looks like Cu2 bracket SO4 2. Again, it is a 1-to-1 ratio, so your final simplified answer is given here at the bottom. And that concludes the end of this video. I hope it has made a little bit more sense, and if you have any more questions, please ask me in class. Thank you.